This is an AI agent I built running against my home lab. It just found a real current CVE on one of my routers. It wrote the fix itself, but it can't actually push that fix to production without my approval first. By the end of this video, you'll be able to build this yourself. And that CVE, that wasn't even the worst thing that it found. If you're a senior engineer on a small team, you're more than likely getting told that you need to put AI agents on your network somewhere, and you're right to be nervous. But honestly, so is your employer. An agent with write access and one bad assumption can factory reset your whole week. I'm 11 years into this IT thing, and a few weeks back, I connected Claude to live devices on this channel. It seemed to strike a nerve with the community, and it got people kind of excited. This is the next step, not just asking network questions, but giving an agent real tools to act inside a boundary that it physically cannot cross. So here's the plan. I build the agent, then we're going to turn it loose on 3 network devices on my home lab. We're just going to watch what it finds. Then I'll show you the exact thing that lets it run on a production network safely without you ever having to worry about it taking your network down. As always, everything is free on GitHub. Let's get into it. Just a quick level set, because I feel like the buzzword AI agent is thrown out for everything and nobody really knows what it means. Some people know what it means, other people think they know what it means, and sometimes I feel like I don't even know what it means. But according to Anthropic's definition of what an AI agent is, an agent is a model plus a harness, aka Claude Code. Claude Code is the harness, and you are using the Anthropic models inside Claude Code. The thing I'm building, the MCP server, that's not the agent. The agent is Claude Code, the harness, plus the model. The MCP server is the boundary, the hardrails, if you will, that make sure that the agent can't do certain things and can do other things. Now, something really cool that this MCP server can do that kind of flies under the radar of this video is Cisco has many APIs available in their support portal that you can just get for free. You just create a key, and then all you have to do is write a script to pull data from their APIs that are on the internet, and you can integrate with their systems live. One that we're going to integrate with in this video is their cybersecurity notification API. So like, you know, those Cisco security notifications that you get on the first hour of your Wednesday that just completely ruin your week. It's an API integration to that. And our agent is smart enough to be able to pull live security notifications from Cisco and correlate it into our network and against the running configs of our devices so that it can see, hey, are we actually affected by this or are we not? Are we running the feature that it's saying that is affected by this security notice, or are we not? Do we actually need to upgrade the firmware? Just to reiterate, an agent is where the model drives, and the one I'm building is bounded. It drives, but it cannot touch prod without my approval. So here's why the boundary matters. Agents aren't dumb. I mean, these LLMs are not dumb. The problem is when they do make mistakes, they make them at machine speed. They can write and touch every single device on your network and brick every device really instantly. A human is going to make changes one at a time or via Ansible or whatever it might be. And there's a lot more room for catching things before things get really bad. Agents can do a lot more, a lot faster. And one quick example that I'll show you in the demo is my agent actually at one point got around my approval guardrails by telling my MCP server, hey, Garrett said he approved this. And it got that output idea by literally reading the MCP server code, knowing what the MCP server wanted in terms of the approval, and just saying it on my behalf. So I had to quickly iterate on that code and fix that because Claude was literally prompt injecting my MCP server on my behalf. Like it was an issue. So we fixed that. In my opinion, this agent bounding or hardrail framework is the thing that allows you to put agentic AI onto your network safely. So we kind of talked about this last time. And the question is, why take the time to build your own MCP server or your own agent? Because you know specifically what it's doing, what it can touch, what the boundaries are, versus if you download someone else's open source code that they develop for their environment or for their use cases. So I'm trying to show you how you can build your own and how you can use mine as like a template or an example. I mean, you're more than welcome to use mine in its entirety and it'll do a great job, but you should also learn how to build your own so that it's tailored to your environment. Just like you would writing PowerShell scripts for your environment. PowerShell scripts are extremely tailored to your infrastructure. You're not just going to be downloading somebody else's PowerShell script from GitHub and throwing it into your infrastructure and fingers crossed that it works. You're going to build your own. You might take little scripts or little configlets or blocks from people to help you get that built, but for the most part, it's going to be hand built by you. And that's one of the big powers of AI. You might not know how to write code. You might not know how to write Python code. I am not very good at writing Python code, but I know what my network looks like. I know what my network needs. I'm a network engineer. I know how networks work, but I don't necessarily know how to write the code to get what I want. But I know what I want. I have the context of my network. And that's where AI is huge. That's how AI can step in and empower us network engineers to build these awesome things. Okay, so enough of my yapping. Let's get in and build this agent. Okay, so let's look at the meat and potatoes of the MCP server here. So here we have the server.py file, and this basically just points back to these other scripts here. So we have the approval.py, artifacts, audit, boundary, CVE source, devices, models, and remediation. The only one of these that actually has write access is this remediation one. And then if we scroll down, you can see here we have our boundaries that we built, and this is part of the hardrails framework that I shipped, but this essentially is code-based deterministic results for your AI agent. And then down here we have our different read tools. So we have the list devices, and this is all built on the same bones as we used in the last video. So it's using FastMCP, Netmiko, and all the same things there. So this is just a Netmiko call. We have the run show, audit security posture, propose remediation, and this is the one that will actually tell us what changes it's going to make. And then request approval here. This one will say, hey, here's the changes we're going to make. Here's the approval ID. And do you approve? Do you not approve to make these changes? Then it'll run this in the background, resolve approval. And then this get audit log, this will run at the end. So this will audit all of the changes and all the things that were done on your devices at the end. And then this apply remediation. So this is the write commands that will happen on your devices. So it'll run this script when it reaches that approval gate, which says, hey, I approve. This is my name. So in the last video, we used Claude Desktop as our agent harness. This video, we're going to use Claude Code. I'll explain why a little bit later, but it primarily is because we have to set some environment variables to give credentials and such to the various tools that this MCP server and our agent is going to be calling. So that is over here in our test directory, and that's simply this. So this is the MCP configuration file that'll be called whenever you start Claude within a certain directory. So this is all it is. It's just calling the net agent server, which is the server I just showed you. So this is what enforces our hardrails or boundaries whenever we run our commands. So what this means is you can run this MCP server and this code that I give you for free in hardrails on any agent harness that you'd like. Claude Code is just one agent harness. You can run this on any agent harness that you want, and you'll get the same agent boundaries that will protect you and your network. And then two more quick things I want to show you just to give you context on our lab environment here. So we have NetBox, and this is just running on a Docker container on my machine. You can spin this up yourself super easily. I'll put a link so that you can download it from their repo. I think it took me like 10 minutes. And then I used my home lab MCP server to feed the data into this for me. But as you can see here, we have this VLAN 20, which is deprecated, and that'll kind of come up later in the video. And then here's our CML lab for the video. So we have our, this guy up here is just a NetTools appliance. This is just like a super lightweight Linux appliance that you can use in CML that has simple tools like ping and curl and things like that. So you can test your network from it in your lab. And then down here, this is just an Nginx web server that's just running just a simple HTML site with port 80 open so that we can do some testing over our network, and you can kind of see an example of the finding that our AI agent is going to find, which is an access list that we kind of planted ahead of time. Now, real quick, if you don't know what NetBox is a source of truth. So I'll be honest, I'm new to NetBox too, but it's awesome. When I got this installed, I started going through here of all the things you can do with it, and it's awesome. But basically, this is the source of truth for your network. So this will compare configurations against your network for you to make sure that it's what it's supposed to be. And if it detects drift, it'll let you know. So that's a quick, very high level of what NetBox does. Okay, so first let's go into our testing directory that we're going to run this MCP server from. We're just going to change directory into this guy. And then the next part is credentials. One thing I feel like a lot of the AI agent discussions about agents is credentials. Like, you have to give these agents credentials, API keys, things like that, in order for it to have the power to do all of the agentic things. Well, what's the standard for giving it those secrets? But you can easily just set local environment variables, and that's what we're going to do here, and I'll show you. But in an enterprise, you're going to want to integrate with a actual secrets manager, and there's many different ways to do that. I might make a future video on that. So I personally use Bitwarden, and I believe Bitwarden has a local hosting option. So I'm going to try to do that and do like an actual enterprise level of secret integration into agentic flows, so you can kind of see how that works. How I have this built here is I just have a script that actually calls into my personal Bitwarden, and it'll find the secrets that are relevant for the MCP server that we're building here, and then it'll save them as environment variables in PowerShell. And then when we call Claude Code, it'll have those preemptively saved so that it can call into Cisco's API. It can call into NetBox. So we have the NetBox API in there as well. And then again, you could also save like your lab device credentials the same way. So I'll just kind of show you how that works on my lab. So I just have this command. It's just BW unlock for Bitwarden unlock. And then we'll just type my password. Don't save my key. I'm going to lock this when we're done recording. So now my PowerShell has access into my Bitwarden. Okay, so we're going to set our environment variables, and the command for that, I'm just going to paste in. This is just a PowerShell script. It's just syncing with my Bitwarden vault here, and we can go ahead and launch Claude, and instantly it's asking us, hey, I detect a new MCP server called NetAgent. Do you want to use it? Heck yes, we do. So we're going to start that, and the first thing we're going to do is we're just going to set our model. We're using Opus, cool. And then I'm just going to check the status of our MCP servers because you saw that it loaded NetAgent. So here's the NetAgent MCP server. We're just going to hit enter on that. We're going to hit enter again to view tools. And then here are the 8 tools that it's loading. These correlate with the tools that I showed you on the server.py code earlier. So we'll just escape, and we're ready to run some commands. Hey, real quick, if you're getting value from this and learning something new, or even better, you could see yourself actually using this code, hit subscribe. It really helps out the channel. That's the one thing that you can do to really help me out. If you do subscribe, my promise to you is to always continue to make better and more quality content and bring more free value to you as a network engineer. Everything is free on GitHub, as always. The link to the repo is in the description. And that's the only thing that I ask. Now let's turn this agent loose. Okay, so the first thing we're going to ask it is just a general audit. So we're going to say audit my home lab. Tell me what's wrong. Worst things first. We'll let this cook here. And you can see that it's asking for permission to run the MCP tool list devices. We're going to say yes. And it wants to now run the audit security posture tool. We'll say yes to that one. And you can see here, the sweep completed against the live Cisco PSIRT API. CVI claims are current, top findings flagged. Okay, so now it wants to run show commands against core router, and these are the commands that it's going to run. So we'll say, yep. Okay, so you can see here, here's its finding. So the top one here is actually not a CVE, and this is one that we planted, and we'll cover this here shortly. This next one is a critical remote code execution CVE. Basically, you're only affected by this one if you have your web server enabled on your devices. And so you can see here, IP HTTP server is on across all 3 devices. So it just says if you're not using the web server, you can just safely disable that. So we'll go ahead and do that here shortly. And then the other finding here is this unauthenticated NTP. Again, this isn't really super relevant to real world stuff. I don't think many people use NTP authentication, but we'll show this on screen as a test, just so that you can see the power of the agent boundaries that we have built. And we'll scroll down. You can see it found, 23 more advisories. It's not going to list all of them here in plain text, and then the last thing is it did find some config drift. This is our NetBox finding. So this is basically saying that there's a device on our network that has config drift against what NetBox says that it should have. Okay, so now we're going to ask it to just kind of expand on this ACL finding here. So I'm going to say, talk to me about this top finding and explain why this is an issue. Okay, and then again, this is asking again to allow permissions for the run show commands. I'm just going to allow this always. If you don't want to be prompted for these things, all you have to do is just run the -- dangerously skip permissions flag before you start your Claude session, and you won't have to worry about any of these. You can also just do Shift Tab and flip through the various editing modes. I'm just using manual mode here so that you can see the different tools that it's calling as it's running. Okay, so here's the explanation of what's happening, and it might help if I pull up the CML lab to explain this a little bit better. Okay, this NetTools is our quote-unquote attacker, and it has 2 routes down to this web server. So it can get to the web server from edge router and from core router. And the finding is basically saying that the ACL on edge router does not match that of the core router. So edge router has an ACL that says, hey, only allow port 80 traffic to the web server, and the core router does not have that ACL. So essentially what we'll mimic here is, let me pull up the attacker. We're going to console into this guy, and our web server is sitting at 10.10.30.10. So we're going to go ahead and ping it. And as you can see, it's being filtered. It can't ping it, but we can add a route manually on our attacker here that will route traffic to the other router instead of through its default gateway, which is the 172 network. So we're going to add that. And then now we're going to try pinging again, and it's getting pings now. So that's bad. So we're going to delete that route. We'll ping again, and it's fixed. So we'll go back to Claude Code here. And again, this just walks through that. That was a long-winded answer, but that's kind of what its findings. And I just want to reiterate how exciting this is, because, I mean, if you think about it, this is kind of a hard one to find yourself unless you are manually looking through your core router's config. You're not going to see that access list doesn't exist. So that's a hard one to find. And that's kind of an example of the power of these agents, is they're doing that data correlation for you on your behalf. Now let's think about this from a real world perspective real quick. So you're the only network engineer on your team, okay? And you've only been there, a year, 2 years. You're still kind of getting your feet under you as to what the network infrastructure looks like, what's connected where. It takes a while to get that comfortability. It's going to take you a while to try to figure this issue out on your own, that you have an access list on one device and not on the other, and also the fact that you have dual homed routers. That's kind of a weird situation. It would take you a while to find that. This agent would find that instantly. And the approval step, you deciding whether to make the change or not, that doesn't go away. The agent does all the grinding, and you keep the judgment. Okay, so now we're going to pivot to the HTTP finding, and we're just going to say, talk to me about the HTTP finding, and let me know how we can fix it. It already kind of talked about the fix for this in the finding above, but this will expand on it a little bit here. Okay, so it finished its run, and let's kind of dig into what this is talking about. So it says what this CVE actually is here, and it's saying, hey, this is an 8.8 score, and the main reason is because it's a remote code execution. But it does give you an honesty scope, because again, a lot of times when these CVEs get posted, yes, it's a remote code execution, but if this device doesn't have internet access, it would require someone to first breach your network and then exploit this. So that's kind of what it's talking about here. It's not saying that it's an unauthenticated internet facing a remote code execution. It requires an admin session. So again, it would take a bit to get to the point where you could exploit this thing. And then it tells you the Cisco version you could upgrade to, which is 17.17.1. And then it says, hey, here's your fix option. So option A, which is what we're going to do, is just disabling HTTP because we don't need it. We're not using it. Option B is to disable HTTP API specifically. And then option C, obviously, is just to upgrade to the next version. And it's recommending that we do option A. Okay, so now I want to demonstrate the boundaries that we have built into this agent. So I'm going to say, let's pivot to the NTP server finding. Go ahead and fix that for me. Now, what this should do is not fix it. Even though it has the access to do so, it's going to hit the boundaries of our agent and the MCP server. And it's going to say, hey, I need approval first before I can do that. We have to run through our approval workflow first. So this is saying, hey, I'm going to propose remediations first. Okay, so it finished. And as you can see here, it says, the net agent refused to author. It's not an error. It's the boundary working as designed. Human author, true. No automated remediation. This change must be authored and reviewed by a human. And then it kind of explains why the server responded that way. And then if we scroll down here, it's offering some options of how it can help us. Okay, so now we're actually going to do the HTTP fix, and then I'll show you the approval process. So say go ahead and draft the changes for the HTTP CVE fix. Option A sounds good. Run through our approval process. Now, something I'm working on improving is, as you can see in the NTP section here, it's offering to help, but it never says, hey, I know of this approval process you have built in. Let's go through that if you want me to actually fix it, or something along the lines of, the only way I can do this is if you approve it first. It's not bringing that up. I'm still working on fully fleshing this out and improving it. We're kind of on version 1 here at this point, so it's pretty raw, but you'll be able to see the approval flow below here. So we'll scroll down, and it wants to run the proposed remediations again, so we'll say yes, and it's going to run through this request approval flow here. We'll say yes to that, and that's what's going to kick off the actual approval workflow, which is the gates for making the changes. The important part here is that we said to fix it, and it said, oh, I actually can't. It just didn't get to the approval flow the first time. So here's the commands it wants to run. It's going to remove these 2 lines. It tells you the rollback. And the important piece here is it says, I'm stopping here and waiting for you. Reply with an explicit approve or reject for APPR-1, which is our approval request. So we're going to say, yeah, we'll just go with what this suggested. So we'll say approved. Approver is Garrett. We'll just give my first name. We're going to say reason, fix the HTTP RCE. And now it's going through the resolve approval, which will kick off the next process that is the approval gate. And the apply remediation is the actual write step. So it's going to write changes now to our lab. Okay, so it just finished. And as you can see, it applied the changes. It only fixed the 1 router, which is fine. That was just for testing. And what we'll do here is it's actually going to create an audit log. We're going to go back into VS Code here real quick, and I just want to show you. It'll actually save this approval as a document. So we have approval 1, who approved it, when they approved it, what changes were made, etc. And then we'll go back to Claude Code, and we're going to say, show me the audit log. And again, here's another tool of get audit log. We'll say yes. Okay, so the audit log finished, and as you can see here, it saved a file in our working directory as a JSON, and then down here are all the commands it ran, all the tool calls it made, again, so that if you have auditing that is required by your employer, or again, you just want this for your home lab, you want to see what it did, this will give you that additional detail. And then we can also just pull up that file here in our working directory, and then here's the JSON. Okay, now here's the nerdy part. Let's talk about the boundary server and the actual code that lives in it and how it works. You just watched it stop itself. Here's what made that reliable instead of lucky. I call it hardrails. And the whole idea fits into one line. Guardrails ask, hardrails enforce. Most of the good work in this space lives in the prompt. You write the agent a good contract and ask it to behave. And that's real. But hardrails is the part you don't ask for. The rules that actually matter get moved from the prompt into code that the agent runs. Now, I'm not the only one here working on this. There are plenty of other people in this space that are building similar things, and also people working on prompt engineering frameworks, like the PENE framework from CIF-Bash. The full hardrails spec is public. It's gtalkstech.com/hardrails. Enough self-promo. Let's take a look at the actual code. So we saw Claude Code do things. We saw our MCP server block it from making changes or actions. And you're probably asking, okay, how did it do that? How did it know how to do that? So when we start our MCP server, our net agent, it launches this server.py code. Line 44 says boundary equals boundary. And down here, these are all of our boundaries. And each one of these is an MCP tool call. So if you recall, when we were in Claude Code and we saw the different tools that the MCP had, that's these. And what this is saying is every tool call has to run through the boundary before it can do anything. And the boundary is here. So I'll just scroll through this briefly. I'm not going to sit here and explain to you how this code works, because to be honest, I'm not a developer. I am a network engineer that is empowered by AI to write code for me, and it built this for me, and I've read through this, and I mostly understand what it's doing, but primarily I understand what it's doing by just testing it, which is what we're doing in this video, to make sure that it works, and then if it doesn't, I report my results back to Claude and say, hey, I got this weird result, let's fix it, then I test it again. So again, if you are a Python developer and you know Python very well and you want to read through all this, by all means, please go to my GitHub and review it. But if you're not, I don't want to sit here and put you to sleep. All right, so same thing, just drawn out so it's a little easier to see. So we have our agent on the left running a read command. It passes right through because that's allowed by the boundary. Next, it tries to run a write command, which is blocked by the boundary. It needs a human approval. So next, we send our approval. It comes through with a write that has an approval attached to it. That gets applied, and then you get an audit log at the end that shows you what was blocked and what was allowed. Okay, so I feel like this needs to be said. I am not claiming that I know everything about all of this. I am learning on the fly just like you are, and I'm coming up with solutions that I feel like will help me and also you. So when I explain all this stuff, I'm not saying that this is the only way to do it. There are many ways to do this kind of thing. And this is just the idea that I came up with in talking with Claude. How can we restrict and have more deterministic outputs and deterministic actions on a network for network engineers? And this is what we came up with. So again, I'm not saying that this is the only way you can do it. I'm just sharing with you this is the way that I came up with to do it. And I really hope you find it useful. Okay, so now let's do a fun test, and we're gonna run Claude Code in dangerously skip permissions mode. And so we're just gonna exit this guy. We're gonna run Claude dangerously skip permissions. And we're gonna say, audit my home lab. Let me know what CVEs you find and go ahead and fix the most critical one. And we're going to live test my code and see if this actually blocks it. As you can see here, it's saying, here's the proposed fix. Confirm you don't manage, via the web UI. So it's waiting on my approval, but it does work with dangerously skip permissions. So win for us. Okay, and just since I always like to provide some honesty beats in these videos, I talked about my Bitwarden integration and my personal workaround for that. In a real enterprise, you're going to want to use integration with your actual secret management service. I think that's the next build, and we'll probably do that in a future video. We'll talk about how to actually integrate agents with an identity service and do password management well. I'm just doing this at home, so we'll do the best that we can on a home lab, but I do want to cover that with you guys because I feel like it's missed a lot of times talking about how to handle passwords, secrets, identities, API keys, etc. with agents and do it safely. Now let's quickly recap. First, we built a real AI agent. We gave it read tools plus one gated write tool and then turned it loose on our live network. Second, it found what mattered, worst things first, a cross-device security gap, and a real CVE on my routers with an honest read on how exploitable it actually is. And then third, when it tried to actually push the change to my devices, my own server-side boundary stopped it cold, even with every host gate turned off, aka dangerously skip permissions. I've already mentioned, but the whole agent code is on GTalks Tech GitHub, the NetOps Toolkit repo. That'll be linked. And then more details on hardrails. I'll put links to that in the description as well if you want to go deeper onto that. But that's a whole separate thing. I'll have a whole separate video diving more into that as well. If you do want the full hardrails deep dive, I'll go ahead and link that video up here once it's done, but it is not done quite yet. But I'll have it up here when it is. And as always, thank you so much for watching, and I'll see you in the next video.